Good morning, students. Today we are discussing on P block elements. P block elements are from 13 to 17. Group 13 and group 14 we already discussed. Today we are discussing on group 15 elements. They are also called as nitrogen family. Okay, their electronic configuration is NS2NP3. Okay, the members are nitrogen with atomic number 7, phosphorus with atomic number 15, arsenic 33, Sb is antimony 51, Bi bismuth 83. So, first two members, nitrogen and phosphorus are non-metals, arsenic and antimony are metalloids, and bismuth is a metal. So, we can see that down the group what happens? Metallic character increases. Metallic character increases down the group. Increases down. Okay. These elements, these group 15 elements are also known as pnictogens. Pnictogens means poisonous. Okay. So, the outer shell electronic configuration is also given. That is, in the case of nitrogen, S and P orbitals, 2s, 2p orbitals. Okay. In this case, 2p is half filled. Here, 3s2, 3p3, p is 3p is half filled. Okay. And from arsenic onwards, d orbitals are filled. 3d10, 4s2, 4p3. Then 4d10 in the case of antimony, 4d10, 5s2, 5p3. Bismuth, 5d10, 6s2, 6p3. So heavier elements or higher members contains d orbitals also. Okay. Now, next occurrence. In the atmosphere, 78% nitrogen is present in atmosphere. Okay. 78% nitrogen in the form of molecular nitrogen, and in the Earth's crust, nitrogen is present as NaNO3. That is Chile saltpeter. Then also in the presence of KNO3, that is Indian saltpeter, and also present in proteins in plants and animals. Okay. Now, next phosphorus. Phosphorus is present as fluoroapatite family. Fluoroapatite. In the presence of fluoroapatite, that is also this fluoroapatite is in the apatite family. Okay. Fluoroapatite, the formula is Ca9 PO4 6 times CaF2. Okay. This is fluoroapatite. So, phosphorus is present in this form. Okay. This is seen in phosphate rocks. Seen in phosphate rocks. Then also seen in animal and plant matter. Then bones in living cells. Okay. Phosphorus is present. Next, what about arsenic, antimony and bismuth? They are present in sulfide minerals. Next, let us discuss the physical properties of group 15 elements. Physical properties. First, radii, that is atomic radii. Then ionic radii and covalent radii increases down the group. Okay, covalent radii. Covalent radii increases down the group because the size increases, the atomic radii or ionic radii also increases down the group. But this increase is seen from nitrogen to phosphorus. But from arsenic to bismuth, there is only a small increase in the radii. This is due to the presence of completely filled d orbitals. Completely filled d orbitals. Okay. Due to the presence of completely filled d orbitals. So, electronic configuration is given. Okay. So, from arsenic to bismuth 3d10, 4d10. So, all are completely filled. So, due to this completely filled d orbitals, that offers poor shielding to the outermost electrons. Okay. Poor shielding to the outermost electrons. Okay, and thus there is a small increase in atomic radii from arsenic to bismuth. Okay, this is the first point. Now second point, ionization enthalpy. What about ionization enthalpy? Ionization enthalpy. Ionization enthalpy decreases down due to increase in atomic size. So, down the group size increases. So, ionization enthalpy decreases down the group. Decreases down the group. Now, if we compare group 15 with group 14. Group 14 compared to group 14, we know the period from left to right, the size decreases. Okay, so group 15 elements are in the period having smaller size. So, due to the small size and stable half-filled p orbitals, these are having, compared to group 14, group 15 is having much greater ionization enthalpy. Okay, compared to group 14, group 15 have higher ionization enthalpy due to group 15, the period is having smaller size and half-filled p orbitals. Okay, and half-filled p orbitals. Okay, next point. Third point, electronegativity. Down the group, electronegativity decreases. Okay, down the group, electronegativity decreases. But there is not much decrease in the heavier elements. Next, fourth point, physical state. Physical state. Nitrogen. Nitrogen is a diatomic gas. Nitrogen is a diatomic gas. Okay, diatomic gas. All others are polyatomic solid. Others are polyatomic solid. Polyatomic solid. Next, what about boiling point? Boiling point increases down the group. Increases down the group, but there is a variation. That is, from antimony, in this case antimony is having actually down the group increases, but compared to antimony and bismuth, antimony is having greater boiling point than bismuth. There is a variation. Okay, now next melting point. Melting point. Melting point increases up to arsenic. Increases up to arsenic. Okay. Up to arsenic. What happens to melting point? Melting point increases. Then decreases to. Then decreases to bismuth. So there is a variation. Now next allotropy. Allotropy. All show allotropy except nitrogen. Okay. Except nitrogen. These are the important physical properties of nitrogen family or group 15 elements. Next, anomalous properties of nitrogen. Anomalous properties of nitrogen. First point, nitrogen. Nitrogen differs. Why this nitrogen differs the anomalous properties of nitrogen is mainly due to their small size, then electronegativity, high electronegativity, high ionization enthalpy, and absence of d orbitals. So, due to these reasons, nitrogen differs much from the other members in the nitrogen family. First point, nitrogen exists as diatomic, that is N2. They exist as diatomic. They have triple bond, that is N triple bond N. N triple bond N is a stronger bond, and so bond enthalpy is high. Bond enthalpy is high. Okay. Due to this N triple bond N triple bond N is shorter bond and stronger. In the case of phosphorus, arsenic and antimony, they have single bond. Okay. Then bismuth have metallic bond. Metallic bond in its elemental state. Okay. Now, second point. Catenation tendency is weaker in nitrogen because N single bond N is weaker and N triple bond N is a stronger bond. N single bond N is weaker compared to P single bond PP bond, that is single PP bond. Okay. Catenation tendency. Catenation tendency is weaker in N single bond N compared to P single bond P. Okay. This is due to high inter-electronic repulsion of non-bonding electrons in the case of nitrogen. Okay. Due to high inter-electronic repulsion of non-bonding electrons. Because in the case of nitrogen N single bond N, here the electrons are very close. Okay, the size of the nitrogen is very small, so there will be high inter-electronic repulsion of non-bonding electrons. This results in small bond length of nitrogen. Small bond length of nitrogen. The bond length is N triple bond N. So, the catenation tendency is weaker in nitrogen due to this inter-electronic repulsion of non-bonding electrons. Okay, the nitrogen bond is actually N triple bond N. Compared to pp bond, pp single bond, N catenation tendency is very less. Next, third point. Third property. Nitrogen has unique ability to form p-pi multiple bond with itself and with other elements having small size and high electronegativity. Ability to form p-pi multiple bond with itself and with other elements having high electronegativity and small size. Other elements having high electronegativity and small size. Example, carbon, oxygen. Okay, so nitrogen has a tendency to form p-pi multiple bond, that is with itself, that is N triple bond N triple bond C, N double bond O. Like that, it can easily form p-pi multiple bond with itself and with the other members having high electronegativity and small size. But the heavier elements do not having this tendency because their atomic orbitals are so large. Atomic orbitals are so large. Okay, their atomic orbitals are so large and diffuse, and there will be no effective overlapping in such cases. Okay, no effective overlapping. Due to this, there will not be possible any p-pi multiple bonds in heavier elements of this nitrogen family. Next, fourth point. Nitrogen shows maximum covalency of 4. Nitrogen shows maximum covalency 4. This is due to the reason that the absence of d orbitals. Okay, due to the absence of d orbitals. We know there are no d orbitals in the case of nitrogen. So due to this, they have only maximum covalency 4. So nitrogen cannot form d-pi bond, but heavier elements can easily form because there are d orbitals are present in heavier elements. So heavier elements can form d-pi orbitals. Okay. So they shows higher value, higher covalency. Example, in the case of phosphorus, arsenic, they can form d-pi orbital, the d-pi bond. Example, R3 P double bond O. Greater covalency more than 4. Then R3 P double bond CH2. Another example, R means alkyl groups. Okay. And d-pi bond with transition metals. D-pi bond with transition metals, so they can form ligands. Okay, and form ligands. These are not possible in the case of nitrogen because there is absence of d orbitals. Okay, example, Pc2H5 thrice. This is a ligand. Arsenic. C6H5 thrice. These are ligands. So these are the important anomalous properties of nitrogen. Okay.